This one's a medium SAT geometry problem. And the way we're going to play it is, I'm going to show you how to do it real quick. It's a 30, 60, 90 right triangle problem. And then if you want to stick around, I'm going to take you on a quick tour of 30, 60, 90 right triangles. So the first thing you got to do is read it. In triangle ABC, what's the length of AD? You got to draw the figure. You cannot draw on the computer screen, so you just got to redraw it real quick. There's a lot going on in this figure actually, so make sure you get everything there. There's a 90-degree angle, there's 60 degrees, this side's 12, this is 30 degrees, we got A, we got D, C, and then B is up here. You're looking for the length of AD, so visualize that to yourself. Then you take a look at this triangle, and Evil Testing Service is telegraphing to you that it's a 30, 60, 90 right triangle problem. 30, 60, 90. You say, hey man, I know that 30, 60, 90 right triangles are in the formulas box. So you pop that up. Which one is it? It's this one right here. This is a medium problem, so don't overthink it. We are not in college calculus. This is a big triangle. It's cut into two. This is 60 degrees. This is 90 degrees. How many degrees has to be here? 180 degrees in a triangle, so it must be 30. 30, this is also 90, so how many degrees must be here? Gotta be 60. Do you think these triangles are the same? Yeah, they're the same. They share a middle line. So what's this side? It's 12. So you go and you look at your special right triangles and you say, hey man, what are the sides? They're x, 2x, x root 3. What's the 2x side? It's the hypotenuse side. What's the hypotenuse side here? The one across from the right angle, it's 12. So it says that that side is 2x. So what's 2x? 2x is 12. Okay, well if 2x is 12, I mean, you can do that one easily. X is 6. Where does it say x is? It says it's the little side. What's the little side? It's 6. And that's it. That's the answer. So, guys, some people have passions, like, I don't know, working out, riding horses. I am passionate about special right triangles. I think they're really cool. And you don't have to know anything about them because you get them in the formulas box. But frankly, it would be a lot cooler if you did know about right triangles, special right triangles. So this one we're going to talk about is a 30, 60, 90. It is derived from, it comes from an equilateral triangle. This here is an equilateral triangle. What do we know about equilateral triangles? Well, equilateral means everything is equal. So the angles are all equal. 180 degrees in a triangle, they're all equal, they all must be the same, so they all must be 60. Equilateral, all the sides are the same. We can make the sides whatever we want. Let's use Satan's 30, 60, 90 equilateral triangle. Let's make all the sides 6. There's only 3 ways to cut an equilateral triangle in half. You can draw a line from this point straight down. You can draw a line from this point straight across. You can draw a line from this point straight across. We're going to cut this in half by drawing a straight line down. And when we do that, something very specific happens. We get 2 30, 60, 90 right triangles. What kind of angle is this? Well, this is a straight line. You drew a straight line. 2 straight lines cross, you get 90 degrees. 180 degrees in a triangle, right? 90 here, 60 here. This must be 30. Also, you cut 60 degrees in half. So, it's obviously 30 and 30. This is 30 degrees. This is 60 degrees. You also know that this is 90 degrees. So you have 2 30, 60, 90 right triangles when you cut an equilateral triangle in half. Take a look at the sides. This side's 6. You drew a straight line down. You cut it in half. Half of 6 is 3. So both sides here are 3. So these are all things that you know. This side is 3 root 3. You could just remember that, but let me show you why. How do you find the sides of a right triangle? You know this. They've been telling you about this since 3rd or 4th grade. You use the Pythagorean theorem. One of our small sides is 3, right? So a squared is 3 squared. We don't know anything about the other side that's not the hypotenuse. So that's just b squared. And then what's c squared? 6 squared. So you got 9 plus, we still don't know anything about this side, equals 36. Okay, so b squared, you do the algebra, you take 9 away from both sides, you get b squared equals 27. If you take the square root of b squared, both sides, you get b equals square root of 27. One thing that you can do to multiply two numbers to get to 27 is 3 times 9. Square root's like a prison, because it sucks, right? They're hard to deal with. If you're a perfect square, like 9 is, you get to leave the prison, you get to escape. And when you escape, you become unsquared. So 9 escapes the prison and becomes unsquared. So it's just 3, but that other 3 languishes in the prison. And it's 3 root 3. There you go.